In the middle of winter, here in the lowlands of the Sonoran Desert, I can easily find myself wearing a tank top and relaxing, soaking up the sun rays on an 80-degree day. And this is the case whether I'm around Tucson, Phoenix, over to Yuma, and up to the Bullhead City, Havasu area. But if I'm to travel just a little northeast of these regions to, say, St. John's, Flagstaff, Seligman area, well, then I might find myself in need of some good winter gear. And I might even find myself buried in a ton of snow. Whew, it's pretty chilly up here. You know, I think we'll probably finish this discussion back down south where it's nice and warm. Oh, toasty. So if you're going from Phoenix to Flagstaff, it's about a 2-3 hour drive, maybe 150 miles or so, and you're gonna hit the cold before you even fully get there. And if you're going from Bullhead City to Seligman, well, that's even less of a distance. But these places on the same exact day can be something like a 40-degree Fahrenheit, 5 degrees C difference at the same time. So what on earth is going on here? It turns out Arizona is cut in half diagonally from the northwest to the southeast by a geographical transition of some sort, where the southwest corner of Arizona is Arizona's Basin and Range. We talked a lot about the Basin and Range when we were up in Nevada and Utah and California. The northeast corner of Arizona is Arizona's portion of the Colorado Plateau. And the portion between the two is called the transition zone. Knowing these three physiographic provinces of Arizona can be helpful when navigating the state's geological differences, ecological differences, and weather patterns, and can help you avoid the mistake of painfully packing wrong for vacation. I'm going to Arizona. It'll be warm. I'll pack shorts. Freezing. Should have watched Let's Go Geo first. Here are some interesting features and things to note about the three regions. The Colorado Plateau is a nearly 130,000 square mile or 337,000 square kilometer sized geologic province, where much of the rock strata are horizontally laying sedimentary rocks. It's also known for plains and old grassland ecosystems, narrow canyons with mighty rivers flowing through, and the occasional mudslide. Incredible natural rock sculptures like mesas, buttes, and arches, and the occasional volcanic field, or isolated snow-capped mountain clusters. Those sedimentary rocks are sources of marine fossils, dino bones, and uranium. One incision into these rocks is quite famous, the Grand Canyon. And there on the plateau, elevations can be 5,000–6,000 feet, even when you're not climbing up mountains. The McGoyan Rim, at 200 miles long and a max height reaching 2,000 feet, is one of the largest escarpments in the world. It serves as a geologic boundary between that Colorado Plateau to the northeast and those transition zone mountains to the south. Weathering and erosion actually wears back the rim over time in a northward direction. The transition zone contains highly faulted mountain ranges full of precious metals like gold, copper, molybdenum, all dissected by basins. And if you want to get a feel for the geologic settings that you'll encounter when transitioning from the transition zone to the southern portions of Arizona, well, check out my video I did. We did an adventure in southern Arizona, and we looked at all the geologic features you might stumble across there.
And finally, the Basin and Range province. The Basin and Range is actually a broader province that includes parts of Idaho, Nevada, and California, and southwest Arizona. The Basin and Range is, like it sounds, a series of basins or valleys and ranges or mountain ranges. This topography was created by extensional tectonic forces that literally rift parts of the continent and cause blocks to downdrop while other blocks rise, making mountains and valley sequences across the western United States. The southern portion of Arizona is characterized by the older Cenozoic volcanic features like the sheets of ash flow tuff found in Kofa and the volcanism found around Yuma and Cabeza Prieta, the Sky Islands, and the Turkey Creek caldera, a 12-mile wide caldera that makes for some interesting landscape features in the Chiricahuas. The differences between these provinces have some clear impacts on many things found around the state. Just looking at a geologic map, we can see that in the southern portion, we're more likely to be in Cenozoic features, and as we move to the northwest portion, that's where we're more likely to encounter Mesozoic and older rock features. The economic deposits of highly sought-after ores is also impacted, such as where we're most likely to find copper or uranium. Seismicity is also impacted. We're more likely to feel an earthquake in the northwest corner of the state, with a few exceptions. Since ecology is intricately intertwined in geology, we're more likely to find different species in each of the provinces, like the different types of reptiles and amphibians, and where we'd find different plant species from the iconic saguaro and creosote bush to different types of prickly pears to juniper trees. Even weather patterns are impacted by topography and, of course, hydrologic patterns, such as that of the Colorado River and other important rivers around the state, are impacted by the differences in these provinces, especially those elevation changes. And all of this put together influences where humans settle around the state, including ancient human settlements like the Mogollon and the ancestral Pueblo and the Hohokam, as well as our modern settlements like Phoenix and Tucson.
Well, I hope you enjoyed today's look at the mysterious line that cuts Arizona in half diagonally. And if you're curious about another state that is cut diagonally by a geologic boundary, well, check out our adventure we did in Georgia, where we took a look at the Georgia Fall Line. Otherwise, I'll see you guys here on the next adventure at Let's Go Geo.
Hey, just a real quick message from me, Heather, the host here at Let's Go Geo. Actually, I am host, videographer, photographer, editor, creator, all that stuff. This channel is run solely by me, and I started it because I do love geology and all things related to the topic, and I love teaching, and I thought it would be a great way to bring to people that in the field experience, but digitally. So Let's Go Geo was born. The project's going well, but I have a lot of great other ideas. So if you want to help me out, support me, and help the project move along, you can find me on Patreon, and you can become a fan there as well as get access to exclusive content.